In this lesson, we're going to look at making and testing generalizations. A generalization is when you make a statement that is true about everything that you're specifically talking about. It's a general statement that matches everything. So let's look at how you could do that. So we look at these shapes here and we say, what is true about all of these shapes? You have a rectangle, a pentagon, and a triangle. Generalization 1, the number of sides equals the number of angles. So that's where you look at your shapes, and I'm like, okay, I have 1, 2, 3, 4 sides here, and then you have 1, 2, 3, 4 angles. So this would be 4 and 4. Check, it meets it. This pentagon has 1, 2, 3, 4, 5 angles, and 1, 2, 3, 4, 5 sides. So the number of sides equals the number of angles. Yep. 1, 2, 3 angles and 1, 2, 3 sides. So this generalization checks. It works. All three of these shapes, the number of sides equals the number of angles. Now when we go to generalization 2, we have to test we have to test all the shapes again. So in this one it says they each have 2 right angles. So I come up here and I see in this rectangle I have 1 and I have 2. Okay, there's 2 right angles. Over here I have 1 and I have 2 in the pentagon. So we have 2 right angles, and over here I have 1, and that's it. That's all I have. So this one does not work. The second generalization is wrong because they don't all have 2 right angles. Only 2 of them is. So if I got rid of the triangle, I could say they both have 2 right angles, and that generalization would then be true. With generalizations as well, sometimes they're given like groups, and we got to figure out, well, why is this top group together and then these shapes don't fit? So I look at them and I say, well, this group, what are these? They're all quadrilaterals, 4 sides, and they all are trapezoids, or at least they're supposed to be. You can see that you have the top and the bottom in all of these that are parallel. So they all have exactly one set of parallel sides. Excuse me. And so I come down here and I look and I'm like, well, this one's a quadrilateral. So it can't be quadrilaterals if this doesn't fit. And this one has parallel sides, but it's a parallelogram. All of these sides are parallel. Okay, anything about the angles? These angles all look a variety. You got right angles, obtuse angles, acute angles, acute angles, acute angles, obtuse angles. This one has obtuse. They each have one obtuse and one acute, but this has an obtuse and acute, so that can't be it. I think it has to do with these parallel sides. This has 2 sets. But what about this one? Let's see. Well, it's not a quadrilateral. It has parallel sides here, so it has one set, but wait a minute. I think these sides are parallel to each other, and then this side would parallel this. This one actually has 3 sets of parallel sides, so it wouldn't have the 1. And this is a triangle, and all of these sides intersect, so there's no parallel sides here. But these ones each just have 1 set. So I'm going to go with 1 set of parallel sides. That generalization fits all of these shapes. It fits the ones on top, and it does not fit the ones on the bottom, which means that's an effective generalization. All these have exactly 1 set of parallel sides. Not more than 1, but exactly 1. And so again, that is just how you make a generalization or a statement that tells you and describes a set of shapes.